Here we're going to determine if these shapes are parallelograms. We've already done this from the perspective of the definition of a parallelogram, that the opposite sides are parallel. That's what makes it a parallelogram. But we can also do this from the perspective of all the properties we've just learned. Okay, so the properties of parallelograms, well, parallelograms, the opposite sides are congruent. The opposite angles are congruent. All right, the consecutive angles are supplementary. And the diagonals bisect each other, okay? Those are all true things about a parallelogram, but we can use that to prove that this is a parallelogram as well, okay? So we could work backwards. We look for those properties, and if we have those properties, then we know this thing's a parallelogram, okay? And really, I only need one of the properties in order to do this. But keep in mind that all of those properties involve two things, okay? So like, for example, the first property we learned was the opposite sides are congruent. Well, that's both pairs of opposite sides. And so to show that this is a parallelogram, I would have to have both pairs of opposite sides congruent. Likewise with the angles, both pairs of opposite angles would have to be congruent. Or both diagonals would have to bisect each other. Or two pairs of consecutive angles congruent, okay? So when we look at the properties, every property involves two things. So when I check for a parallelogram, I need to check two things, okay? For example, if I look at this first one, notice it gives me the side values. And so if I want to know, is this thing a parallelogram, I check for the property about opposite sides. Opposite sides in a parallelogram are supposed to be congruent, so I check them. I look at this and say, hey, these sides are congruent, 16.2 and 16.2, but for a parallelogram, both pairs of opposite sides have to be congruent, so I have to check the other sides, 5.5 and a 5.4. Well, those are not congruent, so because both sides didn't work, it's not a parallelogram. That's it. Okay? I'm basically checking that property, and the property says that both pairs of opposite sides are congruent. Well, this one I didn't have both pairs, so it's not a parallelogram. Okay? If I look at this guy, maybe for this one I go the route of comparing the opposite angles. And so when I look at this, I can see here that the opposite angles, the 128 and the 128, those are congruent. That's kind of what I'm looking for. But remember, both pairs of opposite angles have to be congruent, so I have to compare the other two. Well, that's a 52 and an unknown angle. And so what I have to do first, if I want to compare those, is I have to find that missing angle, all right? And so to find that missing angle, well, this is a four-sided figure. I can do the 180 times n minus 2. Remember our little formula for the angles inside a polygon? That's 360. And so these are supposed to add up to 360. And with the angles that I already have, I have a total of 308 degrees. Okay, so when I look at the angles, the three angles that are given, I have 308 degrees. Well, I subtract that from the 360, and that gives me a 52. So now I know my missing angle. If I come over here and mark that guy, the missing angle is 52 degrees. Well, now I can see that those opposite angles are also congruent. So because both pairs of opposite angles are congruent, I can safely say that this thing's a parallelogram. Okay. I could have also used consecutive angles for this one, but we'll do that in the next example here if we look at this one. Okay. So for this one, I could do the same thing. I could find that missing angle and see if the opposite angles are congruent. Or I could just check consecutive angles. But keep in mind, once again, so I would check these, but then separately, I would check the other pair of consecutive angles. Remember, every angle has two consecutive angles, so I have to check each. So like here, when I add these guys together, it gives me a 185. And when I add these guys together, it gives me a 185 as well. And so when I look at that, well, neither of those added up to 180 like they're supposed to, so this one's not a parallelogram. And it's possible that I would have one that equals 180, but the other one doesn't, okay? But again, the property is that both of those have to equal 180, so this one's not a parallelogram. So I'm just checking the properties, okay? But each property involves two things. Last one here, the diagonals of a parallelogram are supposed to bisect each other. And again, it's two things. Both diagonals get bisected. So I compare each. I look at the first diagonal and I say, oh, it gets broken into a 3 and a 3. That diagonal is being bisected. But the other diagonal has to get bisected also. And when I look, it's not being bisected. That's a 4 and a 5. So only one diagonal is bisected. So this one's not a parallelogram. Okay? If both of them had been bisected, well, then it would be a parallelogram, okay? So we're checking using the properties, but every property requires us to check two things, okay?